We keep saying the model learned this, the weights encode that. But picture a brand new model before any training. It is billions of numbers, every one of them set to pure random noise. Static. If you ask it anything, it spits out complete gibberish. And yet somehow that random static turns itself into something that knows chemistry, writes working code, speaks dozens of languages, and argues philosophy. Nobody sat down and typed in those billions of numbers. You could not in 1,000 lifetimes. So how does noise become knowledge with no human writing the answers in? This is training, and it is the most important and most misunderstood step of all. It learns by playing one almost insultingly simple game over and over trillions of times. Take a real sentence from the internet, cover up the next word, force the model to guess it, then uncover the real word and see how it did. That is the entire game. The cat sat on the blank, the model guesses. We reveal, Matt. Here is the elegant part, the reason this scales to the whole internet. Nobody has to label anything. The text labels itself because the right answer was just the next word, sitting right there in the original. At the very start, with random weights, the model's guess is hopeless. It thinks Matt and purple, and they are all equally likely. It is wrong almost every time, but every single time it is wrong, something happens. Every time it guesses wrong, the model first measures exactly how wrong it was, boiled down to a single number. Call it the loss. A huge loss means a terrible guess. A tiny loss means a great one. The entire goal of training is to drive that one number down. And to do it, the model does the crucial thing. It reaches into its billions of weights and tweaks them, ever so slightly, in whatever direction would have made the correct word, Matt, a little more likely next time. Not a dramatic rewrite. A whisper of a nudge. Then it grabs the next sentence and the next and nudges again and again. Each adjustment is almost nothing on its own, but stack up trillions of them, and that is where everything comes from. Now you might think, fine, just nudge a weight, check if the loss dropped, keep it if it did. But stop and feel the scale of this. There are over 100 billion weights. If you tested them one at a time, you would never finish training a single model before the sun burned out. So how does it possibly nudge 100 billion numbers all at once, each in precisely the right direction? This is the mathematical heart of deep learning, and it has a name: backpropagation. In one efficient sweep backward through the network, it computes, for every single weight at the same time, which way to push it and how hard to most reduce the error. All 100 billion in one pass. Without that one algorithm, none of this would be remotely possible. It is the engine under the engine. There is a gorgeous way to picture all of this at once. Imagine those billions of weights laid out as a vast landscape, where the height of the ground is how wrong the model is. Training is nothing more than rolling downhill. Each nudge is one step toward lower ground, lower error, a slightly better predictor. Watch the ball roll down, and watch the prediction sharpen onto the right word in perfect lockstep. Lower means better. But keep two honest things in mind. This landscape is not a tidy bowl with one bottom. It is unimaginably crumpled, full of countless valleys, and training does not find the one perfect lowest point. It just keeps rolling until it reaches somewhere good enough. And the smooth 3D hill I am drawing is really a flat little slice through a space of 100 billion dimensions. The picture is a metaphor. The going downhill is utterly real. But here is the part that should genuinely stop you. To get good at this one dumb little game, predict the next word, the model is quietly forced to learn almost everything. To finish the boiling point of water it has to absorb some chemistry. To finish the last line of a proof, some logic. To finish a story so it actually makes sense, a working model of how people think and act. Predicting text well at the scale of all human writing secretly demands understanding the things that the writing is about. And as models grew bigger and were fed more text, new skills seemed to flicker on: arithmetic, translation, reasoning, that smaller models simply did not have. Now, whether those abilities truly switch on suddenly or just gradually become measurable, is a genuine, unsettled scientific argument happening right now, not a closed fact. But either way, the recipe behind it is almost absurdly plain. A dumb game, a tiny nudge, a staggering scale. And the scale really is staggering. We are talking trillions of words and thousands of specialized chips running flat out for months on end, at a cost of many millions. This is the one part of the whole pipeline that nobody does at home, and it is exactly why a small handful of labs train these base models from scratch, and everyone else in the world builds on top of what they release. There is even a rough rule for how much text a model of a given size should be fed to spend that compute wisely. Though in practice, labs deliberately overtrain their smaller models, stuffing them with far more text than the rule suggests, because a smaller model is dramatically cheaper to run forever once it is done. Train once painfully. Serve a billion times cheaply. So there is the answer to the question we have been dodging since episode 1. The weights were never typed in. They were grown. Start from pure random noise, play guess the next word trillions of times, and after every wrong guess, nudge every weight a hair downhill. Do that long enough at a big enough scale, and the structure of language, and the world hiding behind that language, slowly precipitates into the numbers. But here is the catch that sets up everything next. A model trained only this way is not ChatGPT. It can do exactly one thing: continue text. Ask it a question, and it will not answer you. It will just predict what words might plausibly come after your question, like the internet babbling endlessly on. So how do you take this raw, rambling text predictor and turn it into something that actually listens and helps? That is the most important transformation in the entire series. Next.